welcome to my channel. Today I will be discussing the Leetcode Daily Problem, concatenation of consecutive binary number. So in the question we are given a number. For example, let's say we are given number 3. The input is 3, and according to that we have to print the output. So what is the question asking? So the question is asking that from traversing from 1 to 3, okay, so from 1 to 3 we will get 1, we will get 2, we will get 3. Now what we have to do is we have to convert these numbers into their corresponding binary numbers. So for binary number of 1 is 1, we'll just have 1. Binary number of 2 is 1 0, and for 3 it will be 1 1. Now what we have to do is we have to concatenate these numbers. So after concatenating we will get 1 1 0 1 1. So a new binary number that will be formed is this, and what we have to do is now we have to convert this binary number into its corresponding decimal number. So what will be the decimal of 11011? It will be 27. So our output is 27. So for the question, what approach can we go through? Okay. So first thing that can come in our mind is, okay, we will have for loop from 1 to that number n. So let's have a for loop. We will have a for loop from int I equals to 1, okay, and then I will go till n, and then I plus, right? Now what else? Next what we are doing is we are converting this decimal number to its corresponding binary number, okay. So let's have a function that will convert a decimal number to its binary number. So let's say the function is int to binary, right? Now we will send the number I, right? We will send the number I, and what will we get in return? In return we will get a string, okay. So this will return a string, and what we have to do, we have to concatenate that string to a new string. So let's say our new string will be equals to whatever binary string we are getting. So from this, what's happening from this is, for n equals to 3, what we are doing, we are concatenating 1 2 3, the binary number that will get 1, for 2 we will get 1 0, for 3 we will get 1 1, and after the for loop ends, what we will get in the new string, what will be stored? 1 1 0 1 1, right? Now what next? What we'll do, so for the binary number 1 1 0 1 1, okay, we have our indexes 0 1 2 3 4, okay. So as we know, to convert binary number to decimal number, we will start the indexing from right hand side, and then we'll do 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, okay. We will sum them, okay, we'll add them, and we'll get what? This 27. So it's simple. We'll just have a for loop, okay, for loop for int I equals to 0, I is less than whatever the new string we have, new string dot size I plus plus, right? And then if new string of I, yeah, if you have 0, we won't add this to the power 2, okay. So if new string of I equals to what? 1, what we will do, answer equals to whatever the power of 2, comma. Now what will be the power will be 4. So for 0 we are having the index 4, right? So how we will get this 4? This 4 is nothing but n minus I minus 1, n where n is the length. So we can take n as ns dot size minus I minus 1, right? So let's put it in the new variable called index, right? And we can have 2 comma index here, and answer will be answer plus equals to, right? Then next what? Yeah, that's it. But what is the time complexity of this algorithm? Okay, so this will take O of n. Okay, the for loop will take O of n, and also to convert an integer to binary, it will be log of n, right? So this whole loop is taking up O of n log of n, right? Now coming to the second part, what will be the time complexity of this loop? So the new string that we will get, okay, so what will be the size of the new string? The size of the new string will be nothing but this will take log of n. So the size can be written as log of 1 plus log of 2 plus log of 3 plus log of 4 and so on till n. And this is nothing but log of n factorial, right? Also log of n factorial can be written as less than n log n, right? And this is again, so this is n log n, this loop. This for loop is taking, let's say, n log n, okay? We'll consider n log n. And now again this power calculation. So this power calculation will take, again in the worst case, it will take what? It will take O of n, right? So this power will take inverted O of n. So in total it becomes, this whole function will return a time complexity of O of n square log n, right? And this is not something we are requiring right now. So how to optimize this code? Okay, so for optimizing this code, we can use a technique of what we can say bit manipulation, right? Let's say what we can infer from whatever the question is asking from us. So if we look at this carefully, or let me just expand this 1 2 3 whatever, I'll just erase this part for right now, right? Yeah. So if I'll expand this, what I can see is for 1 we are having 1, for 2 we are having 1 0, for 3 we are having 1 1. So if I can see that we are adding the answer only when we will have a 1 in here, okay? So what if I say I somehow get to know what is the length of this, which, and the length of the binary string will be nothing but log of n plus 1. So in the binary representation, the length of 2 will be nothing but this number, which is a constant time, right? Now what else we can refer is, okay, so in the binary number, this can be converted in the binary number, it will be 11011, right? And we know that the indexing starts from 0, right? So the indexing will be 0 1 2 3 4, right? So if I start from here, okay, if I start from here, what will be the value? It will be 1, okay? If I start from here, what will be the value? 2, then 4, then 8, then 16. Also we won't consider this 0 because 0 into 4 will be obviously 0. So we will just add 1 2 8 16. Now how will I get this part? So this is nothing but just a multiplication, right? So what I can have is, I can see that I will traverse from 0 to 4. Now to get 4, how will I get 4? Isn't it simple? So if I loop it from 3 to 1, from 3 to 1, and for 3, for 2, for 1, if I get these values, right, then my job is done. So let's say for int I equals to, let's say, n, okay, I will be obviously greater than equals to 1, okay, and then I minus minus, right. Now also, so this is for 3, 2, 1. How will I get 1, 1, 1, 0, 1? Simple, we can just have a while loop, while, and whatever this number is. So this number is currently I. So for I equals to 3, I equals to 2, I equals to 1, what will it go? While I. Take while I is greater than 0. Simple. So while it is true, what I am doing? I will try to get this number. Now what is this number? For 3, what is 1 and 1? So I said in 3 I can have 1 and then 1. If this I mod 2, right? If I mod 2 equals to what? 1. If I mod 2 equals to 1, then we will add this. We will what? We will add this part. This one we will add. So what are in the answer? Let's say in the answer we will add. Answer will be equals to answer plus something will be there. Something. Now what is this something? This something is nothing but the power, right? This something is nothing but the power. So let's say we will have a variable p which will having the track of all these numbers. What I have done basically is I'm checking if b is true. For the initial case we will have 1. So if b is true, then I'll set p equals to 1. Okay. Else I'll multiply p by, every time I'll multiply this p by 2. So here we are basically multiplying it by 2. And also if I mod 2 equals to 1, then I'll just add that p in my answer. So answer will be this. Now also what we are doing next is I got 3 and now I have to divide it by 2 also. So I'll divide I slash equals to 2. Right? And then when the I condition is I becomes 0, we will come out of the while loop and we will go in here and I will be I minus minus. But I has already become 0. Now I will become minus 1. So what we can have is in here I can have another variable called j, right? And I'll also initialize it with n. And in I can have minus minus. Now, what is the time complexity of this solution? So, the time complexity can be said that the for loop is running from 1 to n, so this is O of n, and the while loop will run for log of n. So, this whole loop can have the time complexity of n log n. So, that's it. Thank you.